What's going on, folks? And thank you for tuning in with me. Turn this, turn the music down. Turn it down. And thank you for tuning in with me on another Advent of Cyber stream. And of course, I'm your host, Kiri Bloodrose. Yada yada yada. And I want to thank everybody for tuning in with me. Because of some Discord wonkiness going on up in here, if you can, please support the stream by spreading it around like wildfire and let everyone know that the stream is in effect and in the house. Now look, folks, as a matter of fact, those of you who share the stream on Twitter or Mastodon or whatever, I will give you a free Twitter shoutout and a free Mastodon shoutout if you do that. But folks, I can't even post in my own Discord server. So if somebody can let me know when the server goes back up, I'd very much appreciate it. Anyway, folks, hope everyone's having a good day, despite the Discord wonkiness. You know, it's gonna get to the point where I'm gonna have to basically post my stream in people's DMs, just to let everyone know that the streams are in effect and in the house. But folks, Discord's been, yeah, if anybody, has anybody had any issues with Discord within the past hour? And it's not just the Discord issues that I was having, but it was also the a few other technical problems. I don't know if they were network related or software or hardware related, but I had a few technical issues within the past hour. And, you know, I don't know. I don't know what the deal is. I mean, it could be somebody performing a DDoS attack or something. I don't know. Anyway, folks, why don't we go ahead and, I'll wait for some more people to pop in. I'm not expecting a lot of people to pop into stream. Truth be told, I'm not, because of the fact that, you know, Discord's been wonky today, this evening. And it's not just me experiencing it, several other people are also experiencing it. So, if you can, please post a stream on your social medias, post them on IRC, post them on your Matrix chats, your Rocket chats, wherever. Post them on your fucking Steam groups, your Facebook groups, or post them on other social medias. I'd very much appreciate it. Anyway, before we get to Advent of Cyber, I'm gonna go ahead and launch the log into the laptop. It's been a real crappy day, so But here's another thing, folks. Here's another thing. If Discord doesn't let up the, if Discord does not let up the issues, by, I'd say 8 o'clock Eastern time, then, what we'll do is we'll just do call-ins, we'll just have call-ins go on. Probably over the phone rather than just Discord, because I don't want people calling my Discord up directly. And be like, hey, Kiri. I don't want to deal with that. Anyway. Let's go ahead and get to work on our Advent of Cyber room real quick. Oh, and don't forget Telegram chats, folks. Don't forget Telegram chats. If anybody wants to share on those, I'd very much appreciate it. It's looking like Discord's starting to let up a little bit, but we're gonna see where things go. Thankfully, TryHackMe's back up. TryHackMe's Discord is back up, so I can actually post on there. There we go. And if somebody can please let me know when my server's back up, I'd very much appreciate it. So this is why things are kind of slow right now. It's because of Discord issues. So anyway, folks, let's just go ahead and get started with Advent of Cyber, because we don't have a whole lot of time left. We were gonna do it like 30 minutes ago, but you know how things go with technical problems. So I'm gonna go ahead and also just hang on a minute. I'm gonna go into switchboard real quick. I'm gonna pin a message real quick before we get to Advent of Cyber, telling people to spread the stream around like wildfire. There we go. We'll go ahead and pin this. And I'll manually unpin it after we're done with Advent of Cyber or whatever. I'm hoping it's not gonna be that long of an outage. What the hell is wrong with Discord? I mean, seriously, what the hell is wrong with Discord today? I mean, it's not hard to really DM people, but it's hard to, like, communicate in servers, you know? You know, the self-promo servers, my own server. I mean, I had to literally post, you know, other people's, mostly other people's, sub-promotion servers, so... I mean, I don't know. It could be a DDoS, it could be a hacks, I don't know. The way it looks, it could, if it's a hack, it's probably a DDoS attack on Discord or something, but I don't want to speculate. I don't really want to speculate too much. So we're still learning machine learning, basically. I'm alright, just a little miffed. Just a little miffed off at the fact that I can't really post in my own Discord. So I'll have to do things manually. If somebody can post my stream all over the place, post my stream on 4chan even. I don't care if you post my stream on 4chan. Like, post it on VT or something. Matter of fact, I might do that. It'll probably backfire. I don't want to talk about that, Yeahhhh. Don't start. Don't start. Don't troll my Advent of Cyber stream again. I'm serious. I'm gonna ban you if you do. Where's my message clearer? We're not trolling the Advent of Cyber stream, Yeahhhh. You can troll the unhinged stream, don't troll the damn Advent of Cyber stream. I'm serious. Shut up, Yeahhhh! I'm gonna ban you if you God damn it. I'm gonna ban you, Yeahhhh. Keep it up. Alright, clear the screen, please. We're not... This isn't the damn, How the hell do I... Where the hell's my fucking, thing at? How do I clear the chat? I'm gonna clear the chat in my own, refresh the damn chat, please. Folks, this is not, Folks, this is not part of the TryHackMe stream, so we're just gonna ignore Mr. Yeahhhh, man. He didn't get the memo that the TryHackMe streams, the Advent of Cyber streams are not to be trolled. That's for the other streams, to be trolled. Alright, so we're gonna do, So let's continue before we were rudely interrupted. Okay. So over the past few weeks, Best Festival Company employees have been receiving an excessive number of spam emails. These emails are trying to lure users into the trap on clicking on links and providing credentials. Spam emails are somehow ending up in the mailing box. It looks like the spam detector in detector in place since before the merger has been disabled or damaged deliberately. Suspicion is on McGreedy, who is not so happy about the merger. McSkitty has been tasked with building a spam email detector using machine learning, or ML. She's been provided with a sample dataset collected from different sources to train the machine learning model. In this task, we will explore different steps in a generic machine learning pipeline, different machine learning classification and training models, how to split the dataset into training and testing data, how to prepare the machine learning model, and how to evaluate the model effectiveness. Before moving forward, let's review some of the questions. We need to start the VM today. Yes. Is split screen available? Yes. Do we need to start the attack box? Do we need a direct link? Are we given like credentials to connect directly to the VM? No, no, and no. So we've already deployed the machine with the start machine button at the top right of the task, and we'll go ahead and split the screen, and I'm going to separate this into a different tab. The Jupyter Notebook, which is what we're going to work with again. Remember, guys, we've worked with the Jupyter Notebook in a past Advent of Cyber task. So, it's going to be fun to work with this again. And before we work with it, let me go ahead and get a little bit of monster. Let's have some monster. Thanks for letting me know there's ads playing on Twitch. Which you can still watch the stream over on YouTube as well. So we have two ways for you to watch the stream. One way, I don't think I have ads on YouTube, but please just keep both the Twitch and YouTube streams up, I guess. Anyway. Continuing on. Let's go ahead and start. Jupyter Notebook provides an environment where you can write and execute code in real time, making it ideal for data analysis, machine learning, and scientific research. In this room, we will perform the practical on the Jupyter Notebook. It's important to recall that we will need to run the code from the cells using the run button or by pressing the shortcut shift enter. That's shift and enter. You hold shift and press enter. Each step is explained on the Jupyter notebook for a better understanding, so let's dive into the details. A machine learning pipeline refers to the series of steps involved in building and deploying an ML model. These steps ensure that the data flows efficiently from its raw form to predictions and insights. A typical pipeline would include collecting data from different sources in different forms, pre-processing it, and performing feature extraction from the data, splitting the data into testing and training data, then applying the machine learning models and predictions, which we have a diagram. Got ingestion, then cleaning, pre-processing, modeling, and then deployment. Before starting with the data collection, we will import the required libraries. Jupyter Notebook comes with all the libraries we need for machine learning. Here we are importing two key libraries, NumPy and Pandas. These libraries are already explained in detail in the previous task. Oh, we actually have we can read from this as well. Basically NumPy. Oh, NumPy. Okay. So NumPy is a better pronunciation of numerical Python. So NumPy is the fundamental package for numerical computations in Python. And Pandas provides high-level data structures and methods designed to make data analysis fast and easy in Python. It's built on top of NumPy. Do we have a way to add code in here? No, we don't. Okay. So we can just read through here, I suppose, or we could just keep reading through here. Show. That's good. I'll read through this. So basically, this is the code right here that we imported. Run it and put in this code. I don't know if it'll work, but we'll see. Data collection is the process of gathering raw data from various sources to be used for machine learning. This data can originate from numerous sources, such as databases, text files, APIs, online repositories, sensors, surveys, web scraping, and many others. Here we are using the Pandas library to load the data collected from various sources in the CSV format. The dataset contains spam and ham, non-spam emails. So there's no other explanation here. So you just put in that code right there. Let's set? Yeah, it's set. Let's review the dataset we just imported. The category column contains the email classification, and the message column contains the email body as shown below. And we can review the dataset right here as well. It's basically like the expected output. Data frames provide a structured and tabular representation of data that's intuitive and easy to read. Using the command below, we can use the pandas library to convert the data into a frame. It will make the data easy to analyze and manipulate. It's already imported here. Do I need to put in any codes? Like, I don't know if this will work. I mean, I could probably do it all, like... I could probably make a new one. We'll see how it goes if I run it in here. Oh, it's not gonna let me run it. Well, it's fine. I'll make a new file. I'll see if I can run it. Yeah, I'll have to make a new file. Well, we'll just read through this and then we'll do all the things. It's basically the expected output right there. Data preprocessing. Data preprocessing refers to the techniques used to convert raw data into a clean, organized, understandable, and structured format suitable for machine learning. Given that raw data is often messy, inconsistent, and incomplete, preprocessing is an essential step to ensure that the data feeding into the ML models is relevant and of high quality. Here are some common techniques used in data preprocessing. So you got some techniques. You got cleaning, which will correct errors, spell missing values, smooth noise, handle outliers, and use cases would be to ensure the quality and consistency of the data. You got normalization, which is scaling the numeric data into a uniform range, typically 0 and 1, or -1 and 1. When features have different scales, we want equal contribution from all features. Standardization, scaling data to have a mean of 0, and a standard deviation. I can't read Greek, honestly. Sorry, but yeah. But having a standard deviation of 1, which is a unit variance. When we want to ensure that the variance is uniform across all features, that's basically the use case. Feature extraction, transforming arbitrary data such as text or images into numerical features. And to reduce the dimensionality of data and make patterns more apparent to learning algorithms. Dimensionality reduction, reducing the number of variables under consideration by obtaining a set of principal variables. To reduce computational cost, the use case would be to reduce the computational cost and improve the model's performance by reducing noise. Yeah, I've noticed. Thank you. I just saw it. Now I can post the stream on my Discord now. Discretization. Transforming continuous, I would pronounce it, okay, by the way. Transforming continuous variables into discrete ones. The use case is to handle continuous variables and make the model more interpretable. Text preprocessing. Tokenization, stemming, lemmatization, etc. to convert text into a format usable for machine learning algorithms. Use cases to process and structure text data before feeding it into text analysis models. Imputation. Replacing missing values with statistical values such as mean, median, mode, or constant. The use case is to handle missing data and maintain the dataset's integrity. Feature engineering. Creating new features or modifying existing ones to improve model performance. The use case is to enhance the predictive power of the learning algorithms by creating features that capture more information. Machine learning models understand numbers, not text. This means that the text needs to be transformed into a numerical format. Count Vectorizer, a class provided by the scikit-learn library in Python, achieves this by converting text into a token or word count matrix. It is used to prepare the data for the machine learning models to use and predict decisions on. Here, we are using the count vectorization function from the scikit-learn library. Scikit-learn library. Hold on. We have this code right here, and this is the expected output. It's important to test the model's performance on unseen data. By splitting the data, we can train our model on one subset and test its performance on another, which you can see here in this illustration. You can see this is a bit of an example. Here, variable x contains the dataset. We will use the functions from the scikit-learn library to split the dataset into training data and testing data, as shown below in these lines of code right there. X is basically the first argument to The first argument to train test split or train underscore test underscore split is the feature matrix X, which you obtained from the count vectorizer. This matrix contains the token counts for each message in the dataset. Y, the second argument, is the labels for each instance in your dataset, which indicates whether a message is spam or ham. Test underscore size equals 0.2. The argument specifies that 20% of the dataset should be kept as the test set, and the rest, 80%, should be used for training. It's a common practice to hold out a portion of the dataset for testing to evaluate the performance of the model on unseen data. This is where the actual splitting of data into training and test sets happen. The function then returns 4 values: x underscore train, x underscore test. X underscore train is they're both subsets of the features to be used for training, and y underscore train, y underscore train is basically the corresponding labels for the x underscore train set, and obviously y underscore test is the corresponding labels for the x underscore test set. Now that we have the data set ready, the next step would be to choose the text classification model and use it to train on the given data set. Some commonly used text classification models are explained below. Naive Bayes classifier, a probabilistic classifier based on Bayes' theorem with an assumption of independence between features, is particularly suited for high-dimensional text data. Support vector machine, or SVM, a robust classifier that finds the optimal hyperplane to separate the different classes in the feature space. Works well with nonlinear and high-dimensional data when used with kernel functions. Logistic regression. A statistical model that uses a logistic function to model a binary dependent variable. In this case, spam or ham. Decision tree, a model that uses a tree-like graph of decisions and their possible consequences. It's simple to understand but can overfit if not pruned properly. A random forest, an ensemble of decision trees, typically trained with the bagging method to improve the predictive accuracy and control overfitting. Gradient boosting machines, or GBMs. An ensemble learning method is building strong predictive models in a stage-wise fashion, known for outperforming random forests if tuned correctly. And finally, K nearest neighbors, KNN, a non-parametric method that classifies each data point based on the majority vote of its neighbors, with the data point being assigned to the class most common among its k nearest neighbors. Naive Bayes is a statistical method that uses the probability of certain words appearing in spam and non-spam emails to determine whether a new email has spam or not. So here's how the Naive Bayes classification works. So let's say we have a bunch of emails, some labeled as spam, others as ham. The Naive Bayes algorithm learns from these emails. It looks at the words in each email and calculates how frequently each word appears in spam or ham emails. For instance, words like free, win, offer, and lottery might appear in more spam emails. The Naive Bayes algorithm calculates the probability of the email being spam-based on the words it contains. When the model is trained with the Naive Bayes and gets a new email that says, for example, win a free toy now, that it thinks win often appears in spam, so this increases the chance of the email being spam. Free is also common in spam, further increasing the spam probability, and toy might be neutral, often appearing in spam and ham. After considering all the words, it calculates the overall probability of the email being spam and ham. If the calculated probability of spam is higher than that of ham, the algorithm classifies the email as spam. Otherwise, it's classified as ham. Let's use the Naive Bayes to train the model, as shown and explained below. Have all this information here. So it's already typed in here. Do I need to I'll figure it out later. Like I said, I'm reading through all this. I think I should write in there, but I don't want to. I don't know if I need to or not. That's a problem. So, let's have a look at this code right here. The X_train. This is the training data you want the model to learn from. It's the token counts for each message in the training dataset, obtained from the count vectorizer. And the Y_train, these are the correct labels, either spam or ham, for each message in the X_train dataset. This is where the actual training of the model happens. The fit method is used to train or fit the model on your training data. When we call the fit method, the multinomial NB model goes through the data and learns patterns. In the context of Naive Bayes, it calculates the probabilities and likelihoods of each feature, word or token, being associated with each class, spam or ham. These calculations are based on Bayes' theorem and the assumption of feature independence gives the class given the class label. Once the model has been trained with the fit method, It can be used to make predictions on new unseen data. After training, it's essential to evaluate the model's performance on the test set to gauge its predictive power. This will give you metrics on such as accuracy, precision, and recall. So you got the code here, we got the expected output. The classification underscore report function takes in the true labels, y test, and the predictive labels, predict labels, y pred. Y underscore pred, and returns a text report showing the main classification metrics. Precision, the ratio of correctly predicted positive observations to the total predicted positives. The question it answers is, of all of the samples predicted as positive, how many were actually positive? Recall sensitivity, the ratio of correctly predicted positive observations to all actual positives. It answers the question, of all the actual positive samples, how many did we predict correctly? F1 score, the harmonic mean of precision and recall metrics. It gives a better measurement of the incorrectly classified cases than the accuracy metric, especially when there's an imbalance between classes. Support. This metric is the number of actual occurrences of the class in the data and the specified data set. Accuracy, the ratio of the correctly predicted observations to the total observations. Macro average. This average is the underweighted mean per label, and weighted average. This metric averages the support weighted mean per label. This report gives us insight into how well your model is performing for each class and overall in terms of these metrics. Once satisfied with the model's performance, we can use it to classify new messages and determine if they are spam or ham. So you can see here in this code, and I need to type it in. I don't think I need to. So, what's next? McSkitty is happy that a working spam detector model has been developed. She's provided us with some test emails in the file testemail.csv and wants us to run the prepared model against these emails to test our model results. This is it from the task. Also, expected output, there's some code. From the practical point of view, we have to consider the following points to ensure the effectiveness and reliability of the model. Continuously monitor the model's performance on a test dataset or in a real-world environment. Collect the feedback from end users regarding the false positives. Use this feedback to understand the model's weaknesses and areas for improvement, and deploy the model into production. Run this down. So we ran the code in here. It's already been prepared. We run this stuff in here. We run Tessie mouse. That's CSV. We've run the code in here. I wasn't sure if I needed to type anything or not. I only needed to type one little thing. That was it, I guess. Much of spam. Much of spam, but also much of ham. Oh, right in here. let's see here. Test size is 0.20. Wait, no. Let's see. Run this again. Run. This needs. Okay, just put that in. Stop. And wait. Percentage grade average. Let's see if this is the expected, have a look and see. Position. See if this is right. Okay. Email is spam. I see 3 spam emails in this list. One of the emails has a secret code. We need to look for it. Now we can name you well. Second. There. But I can't copy it. Really, I could, well. No, I can't copy it. I'm gonna have to. Actually. Anyway, no, I can't copy it. There we go. And there's also the fishing module, which you can try out. Alright, we're pretty much done with this. It took me a while, but we're pretty much done with this. I've done the free rooms in the fishing module. They're fun rooms. They are fun rooms. Not gonna lie. They are pretty fun rooms. Okay, let's close it all out. And we're going to shut the machine down. Okay. So hopefully you guys learned a bit. You guys had to see me yell at an annoying viewer. It's one of my regulars, but he gets annoying sometimes when he's like trolling when I don't want to be trolled, because I'm trying to make a playlist of the videos. Alright. Anyway, guys, thanks for it's like Discord's finally no longer being a pain in my butt, so we can go ahead and start posting the stream up again on Discord. Again. That was crazy. Alright guys, let's go ahead and do some chat room shoutouts here in a bit, and then we'll move over to the Unhinged Friday stream. Those of you who are watching on YouTube, thanks for watching the VOD. Those of you who are watching live on Twitch and YouTube, thanks for watching. We're gonna stay on Twitch still. We're gonna switch the streams over on YouTube though, so that we keep things separated. Alright, let's see who we got for chat room shoutouts first. And then we'll get ready for the other stream. I'll go ahead and schedule it. But guys, I want you to know I don't appreciate trolling the Advent of Cyber streams. I'm trying to keep them like, well, just keep it decent. Keep them decent at least. Right, so I'll go ahead and schedule the Unhinged Friday stream on Twitch, on Twitch and YouTube. Alright, we're just going on to Kami Hatsune 7788. We got Mr. Yeahhhh Man, even though he's an annoying bastard. That's pretty much everybody. I mean, it's the same people on Twitter and Mastodon. So why bother doing chat outs? Alright guys, gals, non-binary pals, I'm gonna be back in about 5 minutes. We're just gonna basically refresh the stream and get ready for the Unhinged Friday stream. So stay tuned on Twitch if you're watching, and I'll be right back. As for those watching on YouTube, thanks for tuning in with me, and I will be back on YouTube. I'll be back on YouTube in a bit. Go ahead and move over to the other stream that I'm scheduling, and I will be right back. Those of you watching the VOD, thank you for watching, and I will see you tomorrow for day 16 of Advent of Cyber. Hopefully not as bad. Alright guys, I'll catch you guys on the flip side. Take care guys.